Probability, page 9. Number 5. 2 students are chosen at random from a group of 2 boys and 5 girls, all of different ages. Find the probability that the 2 students chosen will be 2 boys or the eldest of 2 students. Okay, 2 students are chosen at random from a group of 2 girls and 5 boys. Okay. So the first time we choose one of the students, there would be 5 out of 7. There's 7 total, right? So there'd be a 5 out of 7 chance that the first choice would be a boy, right? And the second choice would be, now there's only 6 people left, there would be a 4 out of 6 people because now there's only 4 boys left. You chose one boy the first time. So that would be equal to 20 over 42. What is the chance that we get the eldest of 2 students? Okay, so the eldest 2 students. So this is kind of a more complicated one because there's 2 possibilities. One is that you get the first oldest first, and then you get the second oldest second, and the other possibility is that you get the second oldest first and the first oldest second. And it doesn't really matter which order you get them in. So we need to evaluate the probability of both orders. So, like, okay, so let's say we would say, okay, so the first, to get the oldest one first, there would be a 1 in 7 chance. And then to get the second oldest second, there would be a 1 in 6 chance. And that would be 1 over 42, right? Now to get the second oldest first would be 1/7 also, and to get the oldest one second, it would be a 1/6 chance, and so that'd be 1 over 42 also. And then you could add those 2 together, and then the chance that you would get the 2 oldest people would be a total of 2 over 42. We would add those 2 together. The other way you could think of it is that, like, okay, first of all, the first guy you choose, you don't care if it's the oldest student or the second oldest student, because in the end you want both, right? So then you could say, oh, actually I'm satisfied with either one of the 2, so the first student would be a 2/7 chance. After you choose one or the oldest one or the second oldest one, then the next one would be only a 1 in 6 chance because there's only one of them left. And so that would, you see how it gives you the exact same probability that adding 1 over 42 twice also gives you? So either way, you're going to get the same answer. Okay, 22F, tree diagram. Calculate the probability of each outcome. Now remember, to find the probability of like a compound event, the 2 things happening together, as long as they're independent, all you do is multiply them together like that. And so the probability of getting heads is, or I don't even know what H and M stands for, but the probability of getting HH is 3/4 times 4/5, which would be multiply the numerators together, multiply the denominators together, you get about 3/5. Okay, what about HM? So HM would be 3/4 times 1/5. It would be 3/20, right? Which we can't reduce that, all right? Now let's do a 1/4, 4/5. Multiply those 2 together, we get 4/20. That could be reduced to 1/5. Let's see. What about 1/4, 1/5? So 1/4 times 1/5 would be 1/20. That would be MM. Okay, so those are the probabilities of each of these legs, or each of these outcomes. Alright, now let's do a real problem. Number 1. Of the students in the class playing musical instruments, 60% are female. 20% of the females and 30% of the males play the violin. Okay, so they're just giving you these percentages because these percentages are going to help you fill in these blanks here. Okay? Let's see which ones go where. Of the students in the class playing musical instruments, 60% are female. Oh, they already wrote that one there. Oh, okay. But what about this one? What would this be? They didn't tell us how many are male. Well, there's only two alternatives, male and female. So if 0.6 are female, 0.4 would be male, right? 1 minus 0.6. Okay, then it says 20% of the females play violin. So if you're female, once we know you're female, then the probability that you play violin is 0.2. What about not violin female? Oh, they didn't give it to us. But remember, these two have to add up to be 1, so we know that this is going to be 0.8. What about the probability that you play violin if you're male? Then it says it's 30%, also known as 0.3. The complement of 0.3 is 0.7, so we know this one's 0.7. So that's how you fill that in. So we did complete the tree diagram. What is the probability that a randomly selected student is male and does not play the violin? Is male and does not play the violin. So they want this leg here. Oh, did you remember what we did before? In the example, we multiplied and cascade all the probabilities to get the probability of each one of these. Let's do all those. 0.2 times 0.6 is going to be 0.12. 0.8 times 0.6 is going to be 0.48. 0.3 times 0.4 is also 0.12. And 0.4 times 0.7 is 0.28. Did you know that if we add up all these, we theoretically should get exactly 1? So 0.12 plus 0.48 is 0.6, plus 0.12 is going to give us 0.72, and 0.72 plus 0.28 is 1.0. So we succeed. That's a good check to do. You know, if you total up all these probabilities, then you should always get 1. Okay, so what is the probability that the student is male and does not play violin? 0.28. Okay, what is the probability that the student plays the violin? Okay, so plays the violin, that would be this leg and plus this leg. So we're going to add those two together. We're going to add 0.12 plus 0.12, which is going to be 0.24. Okay? All right. Number 3, suppose this spinner is spun twice. Copy and complete the branches of the tree diagram at right. So this is kind of a weird spinner. Do you see it's got red, black, black, and yellow? It's got black twice. So if each one of these regions is equal, like a 1/4 region, do you see that black is actually worth a half? Black is going to be 1/2 chance, while red and yellow are only going to be 1/4 each because they only occupy 1/4 of the area of the spinner. All right, and then it's spun twice, so we would have a repetition of the same probabilities because these are going to be completely independent. So 1/2, 1/4, 1/4, and it's going to be blue, red, yellow. And we're going to do that, 3 times here. Blue, red, yellow, blue, red, yellow. Little small. Okay, I'm not going to rewrite all those fractions because I don't have very much space. Okay. All right, then it says, find the probability that black appears on both spins. Black on both spins. So that would be which one? That would be black, black. So that would be 1/2 times 1/2, which would be 1/4. 1/2 times 1/2, which would be 1/4. Okay, next one. Find the probability that yellow appears on both spins. Yellow, yellow. So let's see. Let's mark that in yellow. Yellow, yellow. Yellow, remember, is 1/4. And to do yellow again, it would be 1/4 again. So that would be 1/16. What about the probability that different colors appear on 2 spins? Oh, that's a complicated one. So let's do green. And so that would be this one, this one, this one, this one. It wouldn't be red, red. Wouldn't be yellow, yellow, but it would be everything else. Wouldn't be blue, blue. It would be this one, this one. Okay. So, let's see. This first green one is blue and red, so that would be 1/2 times 1/4, which would be 1/8, right? I'm going to blow this up a little bit. This would be 1/8. Blue, yellow would be 1/8 also. Red, blue. Red, blue would be 1/4 times 1/2, which is 1/8 also. Red, yellow would be 1/4 times 1/4, which would be 1/16. Yellow, blue would be, let me erase that, that's messy, B. Yellow, blue would be 1/4 times 1/2, which would be 1/8. And finally, yellow, red would be 1/4 times 1/4, which is 1/16. Okay, so we got 1/8 plus 1/8 plus 1/8 plus 1/8, which would be 4/8, plus we got 1/16 plus 1/16, which is 1/8. So I think we got 5/8 here, right? 1, 2, 3, 4, 5. Yeah, 5/8. So the total for different color on 2 spins would be 5/8. Okay. Finally, find the probability that black appears on either spin. Okay, so which one is black on either spin? That would be first one. It would be this one or this one. Any of those that has black on the first spin is fine. Black on the second spin here. Black on the second spin here. Okay. So we have most of these probabilities calculated. 1/8 plus 1/8 plus 1/8 plus 1/8. That's 4/8, which is a half. Plus we got this one at the top, which is 1/2 times 1/2, which is a fourth. So we got a half plus a fourth. That's 3/4, right? Okay. Number 5. Machine A makes 40% of the bottles produced at a factory. Machine B makes the rest. Machine A spoils 5% of its product, while Machine B spoils only 2%. Using the appropriate tree diagram, determine the probability that the next bottle inspected at this factory is spoiled. Like I was saying, usually IB problems, they kind of guide you to the correct display tool. In this case, it's the tree diagram. So let's see, Machine A makes 40% of the bottles produced at the factory. So first we'll do the Machine A phase. And so it'll, let's see, Machine A phase. It would be like which machine phase. So like which machine. So there's the Machine A and there's Machine B. And the Machine A makes 0.4, already here, Machine A, Machine B. So there's a 0.4 chance that the Machine A makes the bottle. Machine B would make the rest, which was 0.6. Machine A spoils 5%. So like 5%, 0.05 are spoiled. And the rest, 0.95, are okay. And what about Machine B? Machine B spoils 2%. And the rest, which would be 0.98, are okay. Using appropriate tree diagram, determine the probability that the next bottle of inspection at the factory is spoiled. So they're saying, okay, spoiled is this leg and this leg. What is the probability of these two legs? So it would be 0.4 times 0.05, which would be 0.02. And it would be 0.6 times 0.02, which would be 0.012. And so if we added these two together, 0.02 and 0.012, we should get the probability that the next bottle is spoiled, 0.032. Okay. Number 7. The English Premier League consists of 20 teams. Tottenham is currently in 8th place on the table. It has 20% chance of winning and 50% chance of losing against any team placed above it. If a team is placed below it, Tottenham has a 50% chance of winning and 30% chance of losing. Find the probability that Tottenham will draw its next game. Okay, so in the first split of the tree, we're going to have a, they're going to play a team above. team, team above. And the other possibility is team below. Okay. Alright, it doesn't say what the probability is. Oh, I see. Ooh, interesting. This is kind of tricky. What's the probability that it's going to get a team that's placed above on the table? Well, it's in 8th place, right? And although there's 20 teams, there's only 19 teams that could play, right? Because like it doesn't have the possibility of playing itself. So how many of the 19 teams are above it? 7 above, right? And then there's Tottenham. And then below Tottenham, there's going to be the remainder, which would be 19 minus 7, which would be 12, right? So 7 above, 12 below. What is the chance that a team above will be selected? Well, it's going to be slightly less than half, right? It's going to be 7 out of 19. What's the probability that a team below is going to be chosen? It's going to be 12 out of 19. Well, that's kind of an interesting problem. Okay, and then let's see. What is the probability that Tottenham will win? Well, if it's a team that is below it, then it has if the team is above it, then he's going to have a 0.2% chance of win, or a 0.2 chance of winning. 20% converted to decimal is 0.2. 50% chance of losing, which would be 0.5. 0.5 chance of losing. So how much chance of drawing? It would be 0.3, right? 0.3 would be draw. Okay. And then what about if there's a team below? There's a 50% chance of winning. Okay, if it's team below. 50% chance of winning. And then of losing, it's a 30% chance of losing. And then the remainder, which is 0.2, would be draw. And then it says find the probability that they will draw. So that would be this leg and this leg. So it would be this times this and this times this. Okay, so that would be 0.3 times 7/19 plus 0.2 times 12/19. Okay, so I'm not sure. Probably they want this in decimal, but it's kind of hard to say, right? So that would be 0.111 plus 12 divided by 19 times 0.2 is 0.126. 126 plus 111 is 0.237. 237. Okay. Alright, so the probability that they would draw is 0.237. And that is the end of page 10.